Good morning, ladies and gentlemen. My name is Eusebio Katana. I'm Senior Manager in Innovation and Deployment Department at HaminaKotka. It's my pleasure to welcome you to the COREALIS HaminaKotka Demo Training webinar and how HaminaKotka port increasing efficiency step by step. I am delighted that today's event brings together international experts with different backgrounds across Europe. I have the pleasure today to moderate this webinar. I am confident that you will benefit greatly from today's sharing by our distinguished speakers, and I hope that you will be inspired by their experiences, gain insight on transforming your business to a successful growth enterprise and be the agent of change for your business. I would like to express my thanks to all speakers and you to be here with us. Our session has two main parts, namely the speakers part and the question and answer part respectively. Next slide, please. Please let me introduce the webinar session and our speakers. So after my introduction, we'll follow the COREALIS project overview and part of HaminaKotka Living Lab overview. Then we'll go more inside and you'll see three main applications, three main use cases that are already implemented by part of HaminaKotka, namely track appointment system and a planning and simulation tool for containing terminal operations and part of the future serious game. I will close at the end with a question and answer session. Next slide, please. Why COREALIS? What means COREALIS? So COREALIS abbreviation means capacity with a positive environmental and society footprint ports in the future era. From strategic level, on a global and regional level, administrative procedure has been established for freight transport and logistics. On a global level, the various transport modes are regulated within the United Nations framework and also addressed by the World Trade Organization, World Customs Organization, International Standard Organization, and other international fora. On a regional level, various policy considerations and legislations exist within the context of the EU and its EU member states. As you know, a very important role in the developing of the digitization and implementation in transport and logistics. It's under DTLF forum and DigiMove under European Commission policy. As you know very well, ports are essential for the European community, for the European economy and economic growth. At least 74% of goods exported or imported to the EU are transported via its seaport. At the same time, the challenges they face are only getting greater. As you know, cargo volumes are increasing higher, and in the same time, the cargo volume are also arriving in a shrinking number of vessels. So COREALIS proposed a strategic and innovative framework addressing integration and validation of different technologies as part of the novel architecture. COREALIS is also supported by technological building blocks, including new generation of Internet of Things, 5G devices, data analytics, next generation solution for ports, areas, and city ports in order to handle upcoming and future capacity, traffic, efficiency, and environmental challenges. So in the next presentation, you will see how COREALIS use cases have been implemented. You will see amazing technologies that are implemented deployed and validated in the COREALIS project. So we'll start the first presentation with our colleague, Eleni Krikigiani, Scientific Project Manager at Seeability Limited. Eleni has more than 8 years experience as project manager in several EU-funded projects. She has a significant experience in engineering, transport planning, security, and risk assessment. Her research interest includes sophisticated techniques of utilizing geographical information system and remote sensing techniques. Eleni holds a Master of Science degree in urban planning and regional development and a Master of Science degree in geoinformatics, and now she's following the courses in order to obtain her MBA from the National and Technical University of Athens. Eleni, the floor is yours.
Thank you, Eusebio, for the introduction. Can you all see my screen?
Yes.
Okay. I would like to welcome you today on board to this COREALIS HaminaKotka demo and training webinar. This is the project introduction of COREALIS project. COREALIS is a European Commission project funding under Horizon 2020 under the topic of the Port of the Future, which was the MG 7.3. It started back in May of 2018 and it's supposed to last next year on April 2021. It is coordinated by the Institute of Computers and Communication Systems here in Greece, in Athens, and it consists of 17 partners from 9 European and associate countries. Among them, there are 4 research institutes, 5 ports, 4 industry players, 3 SMEs, and 1 ITS association. We have 5 living labs in the respective European port cities, including 3 out of the top 5 in Europe, namely the Antwerp port in Belgium, the Piraeus port in Greece, the Valencia port in Spain, the Livorno port in Italy, and the HaminaKotka port in Finland. What is the vision of COREALIS? COREALIS proposes a strategic innovative framework supported by disruptive technologies such as IoT, data analytics, next generation traffic management, 5G networks, in order to assist ports to handle their upcoming and future capacity, to optimize their port operations, to reduce their environmental footprint, to increase their efficiency and to minimize the traffic within and around the ports, and to be sustainable and to encourage the socio-economic development of the ports. To do so, it comprises of a palette of port-driven and technological and societal innovations. Among them, they are the Port of the Future serious game, which is a simulation tool for decision-making, a track appointment system, which is a reservation system that includes real-time traffic data, the RT port, which is a model-driven real-time control module which supports 5G smart terminal operations, the brokerage platform, which is a cloud-based marketplace for leasing and exchanging intra-port assets, the PORTMOD, which is an optimization modeling tool for container terminal operations, the innovation incubator, which is a thing that making the port the epicenter of the local and industrial urban space, the just-in-time rail shuttle service, which is a feasibility study for the Hydral corridors, the cargo flow optimizer, which is an optimization tool for ocean rail and inland waterway cargo flows, the predictor for asset management, which is an optimization machine learning tool for the efficient use of port assets, and finally the green cookbook, which is a cost-benefit analysis for helping the port reducing its environmental footprint. Here you can see a table, a matrix of COREALIS demonstration and the respective innovation in each living lab. Today, we are going to present the innovations within HaminaKotka port, namely the track appointment system, the PORTMOD, and the Port of the Future serious game. Now, I will give the floor to Julia for showcasing our project video that, in a nutshell, presents the whole overview and the background of the project.
Ports are essential for the European economy and the economic growth, as the 74% of goods exported or imported to the EU are transported via its seaports. At the same time, the challenges they are facing are only getting greater. Volumes of cargo are increasingly higher. Number of vessels is shrinking. Cargo flows types are changing due to technological trends, such as Industry 4.0. Cargo port operators are struggling to comply with the increasingly stricter environmental regulations and societal views for sustainable operations. COREALIS' vision is to embrace circular economy models in the port strategy and operations, to reduce ports' total environmental footprint, to optimize yard capacity and improve safety without major infrastructural investments, to streamline cargo flows in favor of green transport modes, to encourage ports to become an innovation hub of the local, industrial and urban space, to improve port-city stakeholder collaboration for medium and long-term decision-making. To achieve its vision, COREALIS is developing a palette of port-driven, technological and societal innovations, a reservation system including real-time traffic data, a cloud-based marketplace for leasing and exchanging intra-port assets, an optimization planning modeling tool for container terminal operations, a model-driven real-time control module supporting 5G smart terminal operations and IoT, an optimization machine learning tool for efficient use of port assets, an optimization tool for ocean, rail, inland waterway cargo flows, a simulation tool for decision making, a cost-benefit analysis and roadmap for reducing ports' environmental footprint and achieving energy network efficiency, a feasibility study for key port hinterland corridors, a scheme making the port the epicenter of the local industrial landscape. COREALIS innovations are implemented and tested in real operating conditions in 5 European port living labs.
Thank you very much, Elena. So we have learned from your presentation what COREALIS is doing. So now let's see Port of HaminaKotka Living Lab overview to see and to learn from them what they're implementing in COREALIS. I kindly invite Mr. Heikki Jaskelainen, Senior Vice President for Steveco. Heikki has a long experience from different sectors positioned of port operation at Steveco since 1993. He's a board member for Dr. Stevedoring Company, Saimaa Terminals. So, Heikki, the floor is yours.
Thank you. Do you see my presentation?
Yes.
Okay. So, first of all, welcome to Port of HaminaKotka and especially to Steveco. Steveco is the biggest port operator in Finland. We have 5 terminals. One of them locates in city of Hamina, 3 of them in city of Kotka, and one in Helsinki, and then we have operation also in Lake Saimaa area, that is inland in Finland. Kotka Container Terminals, which is part of this COREAL project, locates are operating by Steveco. And Kotka Container Terminal is also the largest container port in Finland. We have feeder traffic to most main ports in Europe. HaminaKotka Living Lab consists of 3 innovation and/or application. Track appointment system, PORTMOD, and Port of the Future serious game. Now I will show you more closely about them. Track appointment system is application to increase efficiency of the incoming track traffic by making the cargo flow more predictable. For us as a port operator, this helps us to offer better service to truck and truck companies by controlling resources according to the amounts of incoming trucks. PORTMOD, that is the software which simulates containers and container handling equipment movement. The target of this application is to simulate machines and control container movements, enable what-if analysis. Third, part of the serious game. This application helps especially us to make long-term strategic decisions and also discuss challenges for the boards and their stakeholders in a constructive manner. This was very briefly our living lab. Thank you.
Thank you very much, Heikki. So we have learned that the port of HaminaKotka will implement 3 innovative applications, namely track appointment system, a planning and simulation tool for container terminal operation, and last but not least, port of the future serious game. Now in the next presentation, you will see more details and how these applications will be implemented, about the technical features, and Ms. Susana Caminals, Business Development Manager at CSG Spain, will present this presentation. She has working in CSG for more than 15 years. She has accumulated a very good experience in innovative solutions for facilitating international trade, cross-border track and trace of goods and people. Over the past year, she has specialized in customs brokerage and comprehensive state-of-the-art monitoring solution for the road freight and sea transport industry. Moreover, Susana has been trained as an auditor for different ISO standards and product certification expert. As business developer, she has rolled out nationwide services and trained dedicated teams. Susana, the floor is yours.
Thank you. Can you hear me well? Yes, I think so. Thank you, Eusebio, for this introduction, and thank you all of you for being here today. I'm Susana Caminals, as well said by Eusebio, and will be presenting you the track appointment system which was developed by SGS for being implemented in the port of Valencia and the port of HaminaKotka. Today we will focus on the experience and the characteristics of the track appointment system implemented in HaminaKotka. Okay. So, I'm sorry, I think that it's not. I'm sorry, I'm trying to go forward, I'm going back. Okay, backwards. This is it. Sorry for this brief interruption. Everybody is familiar with different types of booking systems. We all have experience in booking systems in many activities in our daily life and also in business sectors. We know that, for example, to visit a doctor, to book a ticket, there are special systems for doing so, and also for queuing at supermarkets or visiting a monument. Within the supply and transport industry, it may receive different names, but the concept is always the same. It's an appointment system to get to a place at a specific time so that those being at the other side know in advance who is going to come. The track appointment system within the transport industry is typically used for regulating the incoming vehicle flow in vehicle inspection, border crossing, customs X-ray scanning, to regulate traffic incoming to port premises, and also for managing port terminal operations. Within the COREALIS, task objectives was to create a new type of task that was focused on optimizing the terminal resources and managing the operations to the expected volume, the type of activity, by knowing in advance the volume of incoming trucks and the type of operations to be done. Also, to regulate the incoming traffic to port premises and the city surrounding areas, and to create a channel of communication between the terminals and the drivers or the transport companies to optimize cargo delivery and inform on possible delays or other matters. The positive impacts of the track appointment system mainly are that idle time is reduced both for terminals and transport companies, and this leads to most efficient operations and more productive at terminals. By spreading the track arrivals and departures throughout the day and the week, also traffic congestions are prevented, and this results in a reduction of pollution and improving the sanitary conditions of the port and the port surrounding area. The track appointment system in COREALIS implemented in HaminaKotka was created taking into consideration all the user specific requirements. Colloquially, it was called light TAS because it's a simplified version of the TAS implemented in the port of Valencia, which has more advanced functionalities. The TAS in HaminaKotka is accessed is an online service. It's accessed through a link, and it was started to be used in September last year by one terminal, Kotka Container Terminal Musalo, and which had 3 queues, each of which decided to make appointments every 60 minutes with a capacity of 10 trucks within that hour. During the first year, only one transport company has been using the TAS, but after the experience and the positive results, we will have shortly starting another terminal with 11 queues or warehouses. Before the pilot, terminals had no visibility of the incoming traffic volume, of the type of material, of the type of operation that was going to be performed at which warehouse. It caused queues to form at the port entrance, and truck drivers and transport companies did not know the warehouse they would have to head for until the port gate. When they were told the warehouse they would have to go to, they were assigned the warehouse on the spot. During the pilot, all this has been solved. Terminals have been able to know in advance which trucks, the type of material or operations would be arriving at which warehouse. Terminals have been able to plan their resources and operations in advance, and also have been able to inform the driver which warehouse to go to. As main positive impacts from the use of TAS, we have that queues have reduced at the port gates, and also the idle time at terminals, resulting in faster operations. In fact, now operations are made according to, or reported to be made according to schedule. And if before or at the beginning of using the track appointment system, 85% of trucks were arriving late, according to figures of the last September of 1 month ago, 81% of the trucks were now arriving earlier. And these are quite remarkable results, because only 9.7% of the traffic is using the TAS. As a remarkable fact is that the turnaround has been reduced in 13 minutes. Well, the TAS is being used by different users, which have different roles and functions correspondingly. The administrator is the figure thought for the port authority and has full visibility of all operations. It has the maximum permissions. Then terminals have super users and standard users. Super users are thought for the operations team leaders and have full visibility on the terminal and have advanced permissions, especially for creating, activating, deactivating users, and have full visibility, especially in statistics and reports. Transport companies, hauliers, forwarders, and so on, have also super users and standard users. Super users, also thought for the leaders of the operational teams, have full visibility and the same functions or similar to the super users from terminals. Standard users is the user thought for the operational department, for booking creation, for reserving slots for the drivers. And drivers, which are the ones moving the goods to the port, can interface with the track appointment system, not in the e-platform directly, but through a mobile application that they have installed in their mobile. These applications have limited functions, and drivers will only show when they start the trip to the port. They can also reschedule the trip if they are late, and they will get communications both from terminals and from the users from their own transport company. COREALIS thus consists of different modules. First of all, there is the capacity management module, which is for terminals to define the service hours and the volume, the capacity of trucks that they will be receiving for each slot. The appointment management module, which is used for users to create bookings, and an information module, which displays all the bookings created and also allows to export all the data fed into the task and retrieve it in form of statistics and reports. All these modules are also complemented by another module, which provides the estimated time of arrival when drivers are using the mobile application, which feds the geoposition of the track and allows to calculate this expected time of arrival to terminal. The track appointment system is also thought to be interfaced or with other third-party systems, such as the port community systems, the traffic, city traffic control, or weather conditions. In this slide, we see this is a screenshot of the track appointment system as terminals see it. This slide shows how a terminal can be configured by showing the map, the GPS coordinates, and then within each terminal, one can determine the terminal queues to be selected, and within each terminal queue, how many slots during the day, at which times, what will be the duration of each slot, and the capacity of tracks that can be received at that time. The users are the ones making the appointments in the track appointment system. And this is the first screen that they will see to create a booking. By entering this screen, they will be able to create a booking by following 5 easy steps. First, they select the terminal, they have a scroll down menu. Then they select a queue or a warehouse within that terminal. As a third step, they will select the time slot from a calendar, the date and the time. And then they will introduce the vehicle data and the driver's data, so that the terminal knows the type of, the transport order gets all this information linked, and the type of operation that is to be done, material, and so on. Not all this information, not especially for 4 and 5 steps, is compulsory, but the driver's data is important because it allows to communicate with the driver and to get their GPS location. Here we have the dashboard, the bookings dashboard, which shows all the bookings that have been created, and also if using the mobile application, the driving status is fed into the booking information. In this screen, we have a more detailed view of the driver's functionalities when using the TAS application. The driver will see the booking details of those bookings assigned to him or to her. He will be able to see the real trip duration, the route. He will receive automated alerts, and also the ETA and the driving status. That is, if he is arriving late, early, or in time. The driver will also be able to get notifications from terminals and from users from their company. Communication within TAS happens in two different ways. The first one is the notifications management module, which is embedded in each booking and allows to show messages or to exchange messages between the terminals with transport companies, users from the transport companies with terminals, and the transport company users with the drivers. This is only read mode, a way of communicating by sending read mode messages, which can be sent by SMS, by email, or through the application, the mobile application. The second way of communication is by means of a feedback module, which is in the e-platform, in the track appointment system, and it allows asking and replying. It's for terminals to communicate with transport companies and vice versa, so and be able to solve some issues or some questions that may arise during an operation. The feedback displays it's in a form of a questionnaire and displays the date, the time in which the question was formulated, the user, and then if it's active or it's closed. All this information can be also be extracted in form of reporting, showing the average response time, the queries per user or per company, and so on. And finally, the statistics module is the one allowing to get all the information which has been recorded in the task for checking the task overall performance, for reporting, for defining KPIs, and for monitoring purposes or planning. The users who have the access to this statistics module are the administrator and then the super users from both terminals or the transport companies. All the information is can be exported in PDF or CSV format. And the types of reports, there are predefined reports and customizable reports. And here we have mentioned just a few. For example, one may know how many bookings have been created for a specific period of time and can filter by terminal, by queue, by transport company. You can know if how many of them are active or have been cancelled, and if the driver has arrived early, on time, in time, or late. And just to finish, during 1 year of using the task, new ideas have come up, and here we present some of the topics which have raised most interest among the stakeholders for further developing the task and adapting it to the real needs of the users. For example, it has been mentioned that it would be interesting to develop APIs and integrate with third-party systems. And then a pre-booking function which would be related to a new task user profile, especially when there are forwarders or shipping companies as intermediate companies not dealing with the transport, the ultimate transport of the goods. And then, of course, automatic rescheduling or suggestion of next available slot based on machine learning techniques and analytics. And this would be linked also to suggesting alternative routes depending on the driver's preferences, delivery schedule, traffic congestion, weather conditions, and so on. Well, this has been the very short presentation of what TAS can offer. And if you have any question, I will be glad to answer them. Thank you very much.
Thank you very much, Susanna. So we have learned from your presentation many things about the track appointment system, the role of each module, how the machine learning, data analytics are working. We have also learned about the standard users, super users, and direct business positive impact for the business community. So thank you very much. Now let's see the next presentation, a planning and simulation tool for container terminal operation. I kindly invite Toni Lastusilta, Senior Scientist at VTT, Technical Research Center of Finland. Toni has over 10 years experience in operation research. He has received his PhD in process design and system engineering from Abo Academy University in Finland. He is working he started to work for a German company, GAM Software, regarding the optimization platform providers, and he did many applications in mathematical modeling. So he is working as senior scientist at VTT since 2016, and his research interests are in agile mathematical modeling, result visualization, artificial intelligence, and software solutions. Please, Toni, you have the floor.
Thank you. I hope you can see my screen. So as said, my name is Toni Lastusilta and work at VTT Technical Research Center of Finland. And the topic of this presentation is PORTMOD, a planning and simulation tool for container terminal operations. And I hope that you take the chance to ask questions in case you have any, for example, using the chat box. First, I will give an introduction to PORTMOD. Then I will list the current capabilities. Afterwards, I will give an overview of the architecture, and finally, I will demonstrate the PORTMOD capabilities. In the picture to the left, we can see a photo of Musala container terminal area at the port of HaminaKotka. On the picture to the right, we can see a simplified bird's eye view of a small part of the terminal. When we talk about container terminals in general, they are under constant change, driven by cost efficiency. Both technological advances and changing operational conditions impact greatly the cost efficiency. In order to assist terminals to be cost efficient, PORTMOD aims to be an addition to the available set of tools that helps to improve the cost efficiency and development of terminals. PORTMOD offers the following capabilities: identify inefficiencies and bottlenecks in container flows, identify inefficiencies in straddle carrier and crane operation, estimate the benefit of machine pooling during ship loading and unloading operations. A more extensive description of PORTMOD can be found on the COREALIS website. You can see the link to the website at the bottom of this slide. Please go and check it out. Now I will briefly explain the architecture of PORTMOD. PORTMOD is a standalone Java program that consists of two modules, namely Flow Analyzer that enables the visualization of container flows, and PORTMOD Simulator that allows to simulate machine and crane movements in a terminal. Both modules operate on container movement data, typically extracted from a terminal operating system, in other words, a TOS system. The graphical user interface allows the user to use the features of PORTMOD. Now let's turn our focus on how PORTMOD can help in identifying inefficiencies in bottlenecks in container flows. The graphical user interface is started by double-clicking a starter file. Clicking the Select File button lets you select a move event data file that has been extracted from a TOS system. The other files in the folder are auxiliary files that describes the terminal layout, among other things. Clicking the Flow Analysis button will display the container moves in the input data. The History tab will give a summary of the visualized containers. Now let's turn our focus on what can be done with the Flow Analyzer part of PORTMOD. We can, for example, use the filters to show only export containers. In this case, we can see that the containers have moved from storage yard area towards the cranes in a more or less straightforward manner. We can see that only few containers have moved in the opposite direction for some reason. For example, we can see that 4, 2, and 1 containers have moved for some reason in the opposite direction. If the magnitude of these moves would be higher, then the reason for the moves may be worth to look into, especially if they appear regularly. Next, let's look at the total flows again. We may focus on a particular area or crane. Let's focus on crane 4. We can see that 191 containers moved from crane 4 to area 44. We can also add area 44 to the focus text box and click on the distance button to get the distance between the two locations. In this way, it's easy to quantify the work effort needed, for example, to consider the use of other equipment for container moves for longer distances, for example, the use of terminal tractors or automated guided vehicles. In addition, it is possible to set the focus on several areas simultaneously that may be needed for more complicated analysis. It is also possible to focus on a specific ship event, let's say the export container moves to ship PEGA 05A. We can see how they are positioned on the container yard and question if the current TOS parameters could be improved by some change. In addition, this gives a relatively accurate measure of the work effort needed to load the ship. Now let's turn our focus on how we can identify inefficiencies in straddle carrier and crane operation. Before we start, I want to point out that we have not yet performed the calibration, and hence the numbers do not necessarily make any sense. However, the input data can be used for demonstrating the PORTMOD capabilities. Let's first adjust the date time range to start at 7 in the morning and end at 10. Let's then click on the Simulate button and move the focus to the History tab. Here we can see that 275 jobs were performed with 15 machines. Furthermore, the machine time to perform the jobs were 2,466 minutes. We can compare this to the simulated result. Here we can see that 275 jobs were performed with 15 machines. Furthermore, the machine time to perform the jobs were 2,474 minutes. Hence, the actual operation was 8 minutes faster than what the simulation result gave. Now we can change the date time range to start at 10 in the morning and end at 13. We can see that the machine time to perform the jobs were 2,732 minutes. However, the simulator gave the result 2,589 minutes. Hence, the actual operation was over 2 hours slower than the simulator result gave. With this result in mind, we may raise a question like, what were the issues in the container terminal operation that resulted in our 2-hour higher machine time usage than what the simulation result gave us? And can such issues be avoided in the future? Now let's turn our focus on how to estimate the benefit of machine pooling during ship loading and unloading operations. Before we start, I want to point out again that we have not yet performed the calibration, and hence the numbers do not necessarily make any sense. However, the input data can be used for demonstrating the PORTMOD capabilities. Let's first check the pooling tick box and click the Simulate button. We note that the jobs not involving a crane is automatically filtered out. From the Simulation tab, we can see that the total machine time of 16 machines is 6,614 minutes, of which 27% is waiting. Furthermore, we can see that the total crane time for 5 cranes is 2,545 minutes, of which 36% is waiting. This is the situation where each straddle carrier has a dedicated crane that they serve. We can compare this situation against a machine pooling strategy, where each machine takes the next job to be performed by any crane during ship loading and unloading operation. From the pooling tab, we can see that the total machine time of 16 machines is 10,068 minutes, of which 52% is waiting. Furthermore, we can see that the total crane time for 5 cranes is 2,127 minutes, of which 24% is waiting. Hence, the machine time has increased by over 3,400 minutes and the crane time reduced by over 400 minutes. The increase in machine time is due to the fact that the machines are waiting for a job until the last crane has finished. We can adjust this behavior by using the straddle carrier text box. For example, we can specify that 1 crane in operation may at most have 3 machines in operation. 2 cranes in operation may at most have 6 machines in operation, and so forth. When we are done, we click the Simulate button. Now we can see that the total machine time has decreased to 6,881 minutes, which is 267 minutes longer than in the simulated scenario. We observe that the machine waiting time has decreased from 52% to 29%. The crane waiting time has increased from 24% to 25% when we are using 1 straddle carrier less. To summarize, PORTMOD is a planning and simulation tool for container terminal operations. I first gave a small introduction to what PORTMOD is, then I described the main capabilities and the architecture of PORTMOD. Finally, I demonstrated the capabilities. Thank you for your attention.
Thank you very much, Tony. So very impressive tool. And I've learned also the benefits of machine pooling. I think will bring additional added value to the business community and to the will have a direct impact for the all stakeholders interested to implement such kind of tool. Thank you very much. Now it's time to see one more innovative application, Port of the Future, a serious game. And I kindly invite Wiebe de Boer, which is Senior Advisor, Port and Cost, Department of Harbour, Coastal and Offshore Engineering at Deltairs, the Netherlands. Wiebe has about 10 years of professional experience in harbour and coastal engineering. He did many projects. He was involved in an international project related to port infrastructure, sustainable port development, nature-based solution, and coastal erosion mitigation. He's also research affiliated at the Delft University. Wiebe is a research and development coordinator of future-proof coastal infrastructure, project leader of the Port of the Future serious game, and project developer of Smart Port on Innovation project in the Port of Rotterdam. Wiebe, the floor is yours.
Thank you, Eusebio. I hope you can see my screen. My name is Wiebe de Boer, and I will introduce to you the Port of the Future serious game, which we developed as part of COREALIS. Maybe to start off, why did we develop this serious game? The motivation to develop this was to have a means of stakeholder engagement in port development. And why is that important? Because we are more and more going towards inclusive green growth, which means that we need to focus not only on the economic aspects of ports, but also on the environmental and social aspects. So in this respect, we often refer to people, planet, and prosperity, or profit, the PPP approach. And this makes also port developments quite complex. And on top of that, as Eusebio also introduced in his introduction, there's a lot of well, new challenges also for ports, like emerging technologies such as 5G, the energy transition, and also climate change. So how can we solve those challenges together? There's no single party that can do that. We need to do that with all stakeholders. And that's why we started developing the Port of the Future series game. The objectives of the game are as follows. It's about raising awareness about this complexity, about all the interactions in the port development and the stakeholders. And we do that by simulating real-world events in a digital simulation environment. It's about stakeholder involvement, so get the stakeholders actively around the table to explore and discuss their port of the future. And it has well, also a purpose for, let's say, education to stimulate multidisciplinary thinking and from different stakeholder perspectives. So how did we do that? What is the Port of the Future series game? What does it entail? Well, in principle, it's just a digital simulation tool with a fixture sport, and we deliberately make it a fixture sport so that we can port, let's say, the game to different contexts and different ports around the globe. And you see a picture of this digital simulation environment on the screen. And there are multiple stakeholder groups that play this game to, let's say, think about their port of the future from their own perspective. And the idea is actually that the players are taking a role that is not their own, so that they step into the shoes of others and start to think from different perspectives about the problem. And then they can take all types of interventions in their port of the future. So you can think about measures for hinterland connections or energy supply, port development, can also be nature development. And the stakeholders need to negotiate about those measures and come to a consensus. And then each round select 2 measures to, let's say, work on their port of the future. And those measures, they have scores on the PPP indicators as introduced before, people, planet, and profit, or people, planet, and prosperity. And those measures cost money. So you have a limited budget, and within this limited budget, you need to set priorities and you need to make decisions. And as you can see, if you can see my cursor, you can see then the scores on people, planet, and prosperity, and also the budget are monitored throughout the game, and also they provide then feedback to the players. Okay, what did my actions have for effect, and what does that mean for my next action? So this game has subsequent rounds to work to basically a balanced people, planet, and profit score. Well, for people, we look then, for example, at indicators such as employment, recreation, safety. For planet, we look at, for example, ecosystems and also emissions and climate vulnerability. And then for profit, we look at port city benefits, port profit, and operational efficiency. So the whole idea is that together the stakeholders come to balance green growth. Well, as we already said, there are many challenges for ports, and therefore we also included some scenarios and events. And the whole idea there is that we can make the game then more fit for purpose for a specific port challenge, and also that we can, let's say, work on this challenge more specifically. So some scenarios that have been implemented are climate change adaptation, energy transition, economic stagnation. That is maybe also relevant now in view of the pandemic. Pandemic was not a scenario that we included at the development stage of this game, but well, maybe we should have. Innovation and also sustainable port city development. So the user can then, the facilitator can select which scenario to play, and that is what the stakeholders will, the challenge that the stakeholders have to work on. And then we also have some events, and those events are basically meant to trigger debate and conflict. So sometimes something unexpected may happen. What does that mean for the stakeholder positions? What does that mean for the consensus? So that is also meant to basically stimulate the learning. Well, normally we would play the game live, then it would be a bit more lively and you get a little bit better the grasp of the game, but because of the current restrictions, we do it now with the video to demonstrate a little bit how this would work out. So this is how the game starts. There is a facilitator that's then selecting the scenario to be played. In this example, we have the climate change adaptation scenario selected, and that will set the scores of the people, planet, and profit initially. So in this case, we have to work on people and planet because they are in the minus. Then the stakeholders can select from all kinds of cards. We don't have the cards now, but digitally we show now which type of interventions can be taken, and they will be implemented in the game. Then an important part is that the stakeholders get feedback on their choices. So in this case, there was a brown port development, and it has a positive score on the people and prosperity indicators, and let's say not really an effect on the planet. And this is another measure that was taken. And the facilitator has an important role to reflect, okay, what has happened? What did this mean for the port? Is this what was intended? And then the stakeholders need to decide in the second round, okay, what are we going to do with this additional information? So then they can select other measures. So it's basically the same type of workflow. In this case, they select more, let's say, green measures, let's say the planet measures to bring their score a little bit up. And then again, they get the feedback on what this meant for the port. So in this way, they can round by round together work on their port of the future and discuss the effects of their interventions. We don't show now in this example events, but those can then also be implemented and they will also affect the scores and the gameplay. So at the end of the game, at this stage, then you get an overview of the gameplay, and here you will see the starting situation. In this case, there was a minus on people and a minus on planet, and not so much on prosperity. And we did all kinds of investments, so the budget dropped from 200 to 89, and well, that did very well on the people and the prosperity side, but planet still requires attention. Well, this type of reflection can then also be shared with the stakeholders, with the players, and that can be then the start of subsequent stakeholder engagement to discuss the implications for the real world port. Okay, then. Well, I come to the end, I think, to my very short introduction into the Port of the Future series game. Some concluding remarks to finalize. Well, as I said, the focus is especially on raising awareness and exploring different scenarios together. It's not as such a decision-making tool because there is no quantitative information that helps to make decisions for decision makers. So the game has more qualitative rather than a quantitative character. But the, let's say, outcomes of the game can trigger more quantitative studies later on. The feedback that we received from past experience is that a lot of people see it as a fun and interactive way of learning about port developments and the challenges, and it helped them to better understand the different aspects of port sustainability, but also to step into the shoes of all the stakeholders and to think differently about the, let's say, port developments. So more information can be found on the COREALIS website or on the Deltaurus website, and this brings me basically to the end of my presentation. So thank you very much for your attention.
Thank you very much, Wiebe. So I hope that all of us have learned about this tool, so that this tool will play an important role for future port development, how different disruptive technologies, how different scenarios are implemented in this tool. And last but not least, this tool has a qualitative character rather than a quantitative character. I think it's a very innovative tool, and all port communities system might be interested to implement such a tool. Thank you, Wiebe. Now we move to the part 2 of our webinar, to the question and answer session. Please, if there are questions for different topics, I kindly invite you. I hope that you have learned many things about COREALIS, about the Port of HaminaKotka Living Lab, and how these three innovative applications, namely track appointment system, a planning and simulation tool for container terminal operation, and Port of the Future serious game are implemented, how these tools will have a business impact to the business communities, and how these tools might be used in the near future. So please, if there are questions, please be free to ask our colleagues. You could also use the chat room. So it means that the presentation are very good and all details have presented. So I think it's time to conclude and to summarize. So we have seen that COREALIS will transform the way we move and the way vehicles are used. At the same time, have you seen in those presentations that COREALIS will open up new areas for business development and pave the way for new services, new disruptive technologies for ports and port cities areas. From the local community, from the local stakeholders, with its strong industrial base and supported by an ambitious research and innovation program and a legal framework. This will put forward in this strategy. Europe has also the strength to compete globally in this domain. So what I can say that the Port of the Future technologies presented are not the end. It's not even the beginning of the end, but it's perhaps the end of the beginning. So last but not least, I would like to extend my appreciation to all speakers and you all for making today's event possible. Stay healthy, and I wish you all a fruitful week ahead, and thank you. Thank you very much.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Bye. Thank you.